Hello and welcome to COBOL Ninja Tips. Today we're going to discuss COBOL performance, and in particular the subject of parallel processing. In general, parallel processing in computing refers to the technique of dividing a task into multiple smaller parts that are processed simultaneously rather than sequentially. Imagine a large task as a puzzle. In traditional sequential processing, one person would put together this puzzle piece by piece in a specific order. In parallel processing, however, multiple people work on different parts of the puzzle at the same time, which can be much faster. Parallel processing is implemented in software where modern parallel processing techniques are supported and enhanced at the hardware or system level utilizing multi-core processors, thread management, load balancing, and so on. COBOL is an older programming language primarily designed for business applications and not inherently built for parallel processing like some modern languages. However, the concept can still be applied with amazing results. Here's a classic example where a parallel processing technique can be implemented in existing COBOL applications with minimal code change, slashing elapsed times of mission-critical batch processes. While I'm sure many viewers are acquainted with techniques that will be discussed here, I am certain that for some this will be new and will help them in their effort to create better solutions. COBOL is the #1 language for batch processing. In most cases, the main process will read and process a primary input file. This file serves as the central source of data for the program and often drives the processing logic. In a typical scenario, this file is read in a loop, with each iteration dealing with one record at a time. The data in each record usually determines the actions taken by the program, including reading from or writing to other files, calculations, and decision-making. In most cases, the primary input file records are read sequentially in the order they appear in the file, one after the other, from the beginning to the end, regardless of any logical ordering or keys. In order to implement simple parallel processing in COBOL, we need to ascertain the following. The primary input file is read sequentially based on the arrival or relative record number sequence without any regard to a logical index, key, or order of the records. The actions performed on each record have no direct link to any other action performed on any other previous or future record. Our environment has a batch processing system, and we can run multiple instances of our main program as parallel batch jobs. We're first going to look at what's known as data parallelism in COBOL. In data parallelism, the program uses the same single primary input file. We send parallel jobs, each running an instance of our main program. Each job will process a portion of the input file. We have another solution which is known as data partitioning. In data partitioning, we use multiple input files, each containing a portion of the original primary input file. And in this case as well, we send parallel jobs, each running an instance of our main program. However, each job will process its own personal input file. There are pros and cons to implementing either data parallelism or data partitioning. Both are excellent solutions. When partitioning data into separate files, we need to do a number of extra things at runtime. We need to calculate the total amount of records, divide the records and populate the files we will be using. We need to maintain those files, ensuring the structure is always identical to the primary input file upon which they are based. We'll need to override the file name of the main program to the partition file name of that specific job, and so on. Over the years, I have found it faster and easier to implement data parallelism. The development effort needed is minimal and poses less risk to the overall process. However, in any case, we must always make sure to address issues such as data dependencies between the parallel jobs, for example, record locking or clearing output files. Some data portions may be more complex or time-consuming to process than others, degrading the overall parallel effect. We need to ensure that parallel jobs do not have an adverse effect on the system. In cases where totals were once calculated in one main job, we need to ensure that totals are saved and calculated together when all jobs have ended. And having a mechanism in place that waits for parallel jobs to end and then continues to the next phase of the process. This option is the easiest and simplest to implement. We will split our process into 10 jobs. Each will be sent to batch to run in parallel. Barring any issues I mentioned previously, all we need to do is the following. Add a parameter, one numeric digit, for the main program to access. In the main process script, run a loop of 10 from 0 to 9. Each iteration will submit a parallel job that calls the main program. pass the current index 0 to 9 as parameter to the main program. In the main program, after each read, access the relative record number of that record we just read. If the rightmost digit of the relative record number is equal to the digit passed as parameter, process the record. Otherwise, do not process. Continue to read the next record. What this means is that each job will read the entire file, but will handle only 1/10 of the records. For example, the first job will be sent with the parameter value 0. This means that the first job will only handle records where the rightmost digit of the relative record number is 0. Anything else will be skipped. Processing records by the rightmost digit of their relative record number ensures a randomized spread of data complexity and mitigates the possibility of uneven loads. Results. I've consistently found that using this simple technique has slashed the elapsed times of batch processes to just 10% of what they had previously been. If a job originally ran for 2 hours on average, it now takes 12 minutes. What's best is that all 10 jobs end within seconds of each other. In some cases, I have changed the parameter from 1 digit to 2 digits and the loop from 00 to 99, sending 100 jobs in parallel, and not surprisingly, the elapsed time went down to 1% of the original time. I will discuss the mechanism by which we can, in the course of the batch script, submit a set of parallel jobs, wait for their completion, and then continue in a separate video. Thank you for watching this video. To learn more about COBOL and the COBOL Ninja course, check out our videos on the YouTube COBOL Ninja channel and at the COBOL Ninja website. Thanks again, good luck, and all the best.